Hi, how you doing? I'm Bob Sorensen. I'm a Senior Vice President of Research at a HPC research firm called Hyperion Research. Here today to talk to you a little bit about a study that we've been conducting at the in conjunction with D-Wave to look at perhaps some of the more interesting and compelling issues, what's going on in the quantum computing use case world. First off, I want to thank everyone for attending this presentation, and also to thank D-Wave for inviting me to speak at Qubits. I've spoken at a few of these conferences over the year, and the one thing that's been a hallmark of Qubits is the amazing growth, vitality, and innovation that comes out of these particular conferences. So I'm really happy to be a small part of that. So as I said, let's jump right into the interim results of a study that we've been doing, exploring some of the key quantum computing use cases for users out there in the real world. As I said, I'm from Hyperion Research. This isn't a commercial as much as it's a quick explanation that we are not inherently a quantum computing company. We come to this from the advanced computing world, from high performance computing, from deep learning and artificial intelligence, from big data analysis, from both the advanced computing supplier and end user base. So we look at quantum in some sense as yet another potential opportunity in the advanced computing environment. So we take a little different look at it when we try to fit it into the overall computing environment out there in the real world. So let me just give you a quick survey of what quick summary of what the study objectives were. As I said, we worked in conjunction with D-Wave to really start to extract some key insights from what users are thinking about or potential end users in quantum computing. What is their awareness? What are their requirements from a business perspective? What are the use case and applications that they have hopes and dreams about when it comes to using quantum in their compute environment? What are some of their procurement and buying decisions? And the target survey here was we really wanted to hit key decision makers within the company. So unfortunately, for those here who are listening in terms of being part of the technical crew in quantum computing, we had to go to the bosses here. We wanted to talk to the CIOs, the CTOs, and the C-suite folks who really make the financial decisions to start to think about what their perspectives are from quantum computing. So we wanted to also hit some of the bigger companies. So we really tried to concentrate on organizations that had more than $50 million in revenue and had IT budgets of at least $5 million or more per year. So let me just jump right now to the executive summary here, the kind of the spoiler alerts, if you will. The commercial end user interest in quantum computing is high. As I said, we talked to over 415 different organizations out there. I'll get to that in a minute. And we found that 69% of the companies that we spoke to already have some kind of in-house quantum computing program. And that can vary from a simple monitoring process all the way up to inculcation of quantum computing into an ongoing business process. And we'll get to that in a minute. Another key feature that jumped out at us is the idea that there is some significant pent-up computational demand, whether it be for classical or quantum computers, in terms of how much compute do we do on any given year, and how much more could we do if we had access to more compute capability. And we found that 62% of the companies we surveyed had at least a 25% or more unmet capacity in their existing computational capabilities, showing there's real opportunity here for an for quantum to come in and try to fulfill some of that unmet computational needs. Currently, time to solutions is a major concern of the organizations we talk to. Things like cost and expertise and no commercial solutions were also mentioned. We looked at the companies we spoke to are involved in a wide range of different use cases and applications: data analysis, machine learning, deep learning, optimization, mod sim applications, modeling and simulation, and material sciences. And users are looking for things like optimization. They want to optimize their factory process. They want to make sure that their scheduling opportunities are right on track, or the best they can possibly be. And if we ask them about what do they view as quantum computing opportunities from the business perspective, things like increasing revenue, enhancing business processes, driving innovation, and achieving competitive advantage were some of the things that we heard most from these folks. Well, let me just give you some of the end user demographics so you get a sense of, well, can we really trust these people? Is the data that we hear something that actually makes sense? So strictly speaking, we talked to exactly 415 different corporations or entities around the world who consisted of decision makers, influencers, and stakeholders. And we found that 93% of them, and this was not a self-selection process, we went out to a random group of business executives, and 93% of them said they were somewhat or very familiar with quantum computing, which of course is a self-defined term, how familiar you are, but it just shows that there's a lot of awareness out there right now, even at the C-suite and upper management levels. We managed to get survey respondents, a wide range of countries, and the survey date actually was a relatively short period. We went out only for a period of 9 days, about 3 weeks ago. So the results are about as fresh as you could possibly hope for. So this is just a quick geographic distribution. You can see about a third was the US, but we had strong participation from the UK and the EU. Actually had some interesting results, over 30 companies from South Korea, over 30 companies from Japan. So we felt that we really captured a wide range of geographic organizations. As I said earlier, when we asked the respondents how familiar we were, we saw an overwhelming response in terms of self-defined familiarity with the topic. This is really a breakdown of the budgets of the 415 organizations we talked to. You can see this is a very nice distribution, even though we really didn't want to get anyone below $50 million in annual revenues for 2021 estimated. We got a nice distribution here, ranging all the way from $50 million up to more than $10 billion. That's always nice when you can get a real sense of how much distribution you have. When you put out buckets like this, the worst case scenario is everyone comes back in one bucket and you realize that your bucket was terribly ill-sized. So it's nice to see a distribution here, and it's nice to see such a wide range of organizations, as I said, from 50 million over to 10 billion per year in annual revenues. Similarly, we saw some really nice distribution in terms of IT budgets. The lows, as I said, we didn't want really to look at folks who had under $5 million, but in the $5 to say $50 million range, we had some very, very good participation. But again, the uniformity of the distribution here is something that's satisfying, because it shows that we've really hit a wide spectrum of IT budgets out there. We wanted to focus, as I said, on key decision makers, and you'll see that here when we asked about both what is your particular role in strategic planning and purchasing, 60% said that they were decision makers. They're the guys that are the people that make the final call. And when we asked about who's involved in the procurement process of quantum computing and hardware and software, again, 60% of the folks we talked to said, I'm the decision maker. And if you weren't the key decision maker, you were either a stakeholder, which meant you had some vested interest in what was going on, or you were an influencer. So we felt comfortable that the folks we were talking to are the ones that can translate their vision for quantum computing into reality when it comes to procurement, setting up a capability, and really trying to drive quantum computing into their overall R&D process as well as overall business process. So this is just some titles we asked for folks, what's your title? And as you can see here, CIO, IT director, CTO, small percentage of quantum computing professionals. Sorry for the guys attending this conference, but again, we wanted to hit the guys that write the checks, not the ones that are doing kind of the frontline research. And that was the goal here, and I think we really hit it there in terms of job titles and such. This is an important one, because we wanted to make sure that we had a real crosscut of commercial sectors when we talked to quantum computing end users. I should have mentioned earlier, but we purposely avoided the academic and the government sectors and really honed in on commercial end users. We can look at some of those other organizations perhaps at a later time. But as you can see, good, strong distribution here. Software and internet companies, as well as financial services, were kind of the leaders when we spoke to organizations. But we had some interesting other players as well. Advanced manufacturing had some significant representation. Telecommunications, retail, commerce, insurance, healthcare. Good, strong distribution, which really I think speaks to the validity of the data, because we didn't really focus in on one or two verticals or one or two sectors that either would be very open to quantum computing or perhaps be resistant to the concept. To characterize the organizations that we spoke to, we wanted to make sure that we had a sense of who are traditional high-performance computing, HPC users, the kind of folks that are functionally at the pointy end of the spear when it comes to advanced computing capabilities. But we also wanted to make sure that we were talking to folks who were basically enterprise IT folks, even folks who would never consider themselves perhaps HPC users, but have some interesting advanced computing or interesting compute-intensive workloads that they feel the need to look at. And if you see here, we hit the high performance computing research environment community, but we also reached down into the folks who were looking at HPC, say in a production environment, perhaps like an oil and gas company or a financial company that isn't doing much research, but they're running compute intensive applications in a production environment. But then we started to really get a mix of high performance and enterprise IT environments, either a mixed bag or one that's primarily enterprise IT. So again, the goal here was to get some balance, not just to go to the most esoteric compute organizations out there, but really to get a sense of what's going on in the overall commercial sector in terms of computing capabilities. So hopefully that little peek into the demographics has convinced you that some of the data that's now I'm going to present has at least a certain amount of validity in terms of statistical number, geographic distribution, the types of folks we talk to, and the types of organizations included in the survey. So let's jump right into some of the end user perspectives that we gathered during this activity. So we asked them, how frequent does your organization perform the following common computing tasks? And we asked about machine learning and optimization, mod sim, material science, data analysis, and some other ones. And as you can see here, data analysis and optimization leads the way in terms of what these companies are working on, but diversity really reigns. It's not as if some organizations specialize in certain things. Certainly, if you look at, say, data analysis, big data analysis, or related data science, that was probably the most prevalent one that's being done a lot, but there's a wide distribution, if you will, of the kinds of workloads that these companies are doing. And this is not related to quantum. This is asking them exactly about their overall existing workload on primarily their classical quantum computing, classical computing environment. I should mention that, we kind of preloaded the question here. These are some of the more interesting and compelling applications that we see in the quantum computing realm as well. So it was good to see that the companies that we're talking to about quantum computing opportunities have already started down the path or well entrenched in the path of what they're doing in terms of classical computing in those application spaces. When we asked them, again, I mentioned this in the executive summary about unmet demand. When we asked them about how much computational resources could you use as a percentage of your current total workload, you can see that we had a lot of unmet demand out there. There's a lot of organizations right now that wish they had more compute capability. And for whatever reason, whether it be budgetary or expertise, or they just lack the ability to convert problems that need solving into a computational solution, there's a lot of unmet demand here. And to me, that speaks really well for the quantum computing realm, simply because the applications that they're conducting that we saw on the earlier chart basically is probably the ones that have a lot of significant unmet demand, presenting some significant opportunity for quantum. When we asked them about which are some of the obstacles that keep them from solving some of their computational business problems, too much time needed to implement the solution. That means we've got a problem. Let's hook it up to a computer and see what we can do on that. Well, that time takes too long. It may take months. It may take years to convert that from a thought into a working business process. Likewise, with how much time to solution once implemented, i.e., we have some wonderful solution, but when we throw it on our classical system, it may take too long. It may take days. It may take weeks, or there may be too much demand, so everybody's waiting around for their answers. So those are really some of the big things. And cost has started to creep in here, but we see some of the standards in terms of no relevant in-house expertise, lack of available solutions from vendors, and frankly, just too complicated for them to convert into an easily definable, computable solution. When we asked about some of the state of current quantum computing activity within their organization, and this was the number that I think a lot of folks were really surprised at. I know I was, because it just shows in some sense how much quantum computing has started to gain in terms of mind share and actual activity within a range of commercial sectors out there. 47%, almost half, are exploring options and monitoring technology development. Now that can be a broad range of activities. I know of one company that has a PhD physical quantum chemist who basically spends one day a week looking at quantum computing opportunities for the entire company, and one day he'll make a recommendation. But there's also lots of organizations out there that have full-time staff who are evaluating what's going on. We see a lot of organizations right now are looking at use case analysis and thinking about prioritization, how they could bring in quantum into their overall workload environment. We see lots of companies with fully funded, a quarter that we spoke to have fully funded research efforts. Some, another quarter, are having limited in-house pilot production underway. Production use of quantum computing is out there at 22%. That's over 100 companies right now that report that they have some kind of production capability in quantum. That's their definition, but that number tells you that there's a lot of interest in the sector going forward for quantum computing. And I think that's, again, a really interesting finding that we had. So we asked them about the following business practices that they think quantum could address in their particular their organization, and this really fits in, I think, with some of the use case shortages or shortcomings that we saw earlier. Things like logistics and supply chain problems, manufacturing and factory process problems. I've been talking to a lot of folks out in the world recently, end users, who are very interested in taking what they view as a very complicated material and workflow process in complex organizations, say like in a chemical factory or an automotive factory. And they're trying to figure out, how can we optimize the process to move things through, to produce products with a minimum amount of material, minimum amount of delay, minimum amount of overhead and equipment to get that job done. And that's a really good optimization problem. And that's why I think we saw lots and lots of interest in manufacturing and factory processes. To me, though, I'm no surprise that financial optimization problems right now was considered probably the most prevalent business problem out there right now. And we've seen that with the embracing of quantum computing opportunities in the financial sector, specifically, as well as some of the financial departments across a wide range of verticals. So no surprise there about the optimization issues for the financial sector. But again, the story here is wide range of diverse interest. It wasn't as if all of the interest is in one particular activity or another. It's really, we're interested in seeing what quantum can do to our overall business processes and how it can further the aspirations of our particular organization. And so what were those aspirations when we asked them? And clearly things like increasing revenue, improving research capability, and driving innovation were the top three. I find it interesting that if you really add together research capabilities and innovation, you get 38%. You get more than a third, which is much larger than increasing revenue. So in some sense, right now, a lot of the applications, or at least a lot of the vision for, I think, some of the quantum computing end users or potential end users out there right now, they're thinking more about the research aspects, the value added of quantum to do things like drive innovation and improve research capabilities, than they are, strictly speaking, about just adding revenue. I think once they get past that first stage, increasing revenue, achieving competitive advantage, and reducing cost savings will start to come to the fore. But in this early stage of development, I'm happy to see that there's so much more emphasis right now given on the innovative and research side of the equation, as opposed to just, let's see if we can make something faster or cheaper. One of the things that we did want to make sure when we talk to the right folks is, we asked them about who's responsible for exploring and evaluating new technologies, because these are the folks who are really thinking about what quantum means to them. And in some sense, you need to really understand how to frame a message. How does one go about marketing or thinking about expressing the advantages or challenges of quantum computing in the right language? And so what you find is that if you're talking about evaluation, advanced technology R&D departments, Office of the Chief Technology Officer, kind of the big players there, and you really need to speak to those folks. But ultimately, when you start thinking about kind of who's going to be writing the checks, who's going to be procuring the technology, you need to have, you have to talk to the CTO, the CIOs. You really have to bring the language to the C-suite that makes sense. This has to be sold not as a technological opportunity, more as something that can overall enhance the business prospects of the company. And I think that's an important takeaway from some of this. Is it's the technology is fascinating and appeals to a large segment of any company that's involved in any kind of advanced computing opportunities. But the real value added here is expressing it in terms that the C-suite, that the higher end, the folks who write the checks can really start to understand. So the quick next steps here, because I promised at the beginning, for those who are listening, that this is an interim report, and we asked a whole bunch of questions about specific applications that people could fill in the blanks. And because we went to so many different countries and we translated the surveys into the native languages, you get better survey results if you do that. We've got a whole bunch of different open text right now that has to be translated. And so the next step as we do this is to refine some of the estimates that we got today, but also to start to think about specific use cases that each of these organizations really came forward and says, this is exactly what we're interested in. So that's a quick run through. I think I actually hit my 20 minutes on time. My email address, Bob Sorensen, Hyperion Res, up on the screen there. If you have any questions or comments, if you want to throw some shade on this or whatever, just let me know. But ultimately, I hope this was useful. And I want to thank everyone for listening in. And I hope that the rest of your Qubits conference goes as well as they have gone for me in the past. But thank you very much and have a good day now.
Wow. What an amazing day together. From around the world, we all shared what we're doing in quantum computing, from things that are available and usable and in production today to the future, and how we are going to take this incredible technology forward together. We learned that the Advantage Performance Update is available now in the Leap Quantum Cloud Service. We learned that the CQM solver, which makes problem constraints easier to put onto the system, also available today. I hope you go and check both of those out. We also heard from customers from around the world, NEC, Accenture, Eon, PayPal, Multiverse, Bank of America, and more. There are many people with quantum stories and quantum applications that are ready to share. So I hope you had a chance to participate in that conversation and in those applications. But we also looked to the future. We introduced the Clarity Roadmap. And the Clarity Roadmap really is incredible because it does two things. It brings the power of both annealing and gate model programs together. It also then takes this incredible cross-platform approach with tools and software and makes it easy to use. So all those applications that we talked about today, all those applications from financial services to manufacturing, from pharmaceuticals to mobility, those all become even more accelerated, supercharged even, with quantum computing. Thank you for joining us. We welcome you to tomorrow, and we hope you have a wonderful day.